Mike, I understand Terracotta was acquired by Software AG last year. What set Terracotta apart in the market and made it an attractive acquisition target?
Sure. So Terracotta is a software solution helping enterprise customers manage large amounts of data in memory. So it's a breakthrough technology that delivers in-memory data management for the enterprise. There aren't really any other vendors who are creating such solutions at the scale and performance level that Terracotta is able to do.
Okay. And so with the acquisition, what capabilities did Terracotta bring to Software AG that the company didn't have before? I'm just wondering what solutions, new solutions this enabled, and how Software AG's portfolio may have changed as a result of the acquisition.
Sure. So two things here. Software AG's vision is about providing an agility layer to enable business processes on top of multiple silos and assets, which represent the packaged applications and data stores. Terracotta brings data management to that agility layer. It's very much an agile solution for data management. There are two ways in which this is really important for Software AG. One is actually using that technology within the other product suite to deliver agility to those products, so helping you increase the performance and the flexibility of products like web methods, but also, it's a second thing, to be able to deliver that solution directly to customers. So to be able to improve the performance and scale and bring in-memory computing to sets of applications which are outside the realm of existing Software AG deployments within enterprise customers.
I'd like to go in a little more detail,
Sure.
if you don't mind. I understand that Terracotta has developed a system for utilizing in-memory storage. So it's a way of using caching that allows the user to avoid disk storage. Can you describe how this works and explain what the advantages of that approach are?
Yeah, let me try and explain that in a few simple words. So memory is cheap, memory is super fast. But one of the challenges is that memory is ephemeral. So computer systems have always had memory, and application programmers are able to use that memory. But memory in itself goes away. It isn't synchronized between multiple machines. People have traditionally used databases, which, that central point where everything you do is remembered forever, is transactional, is consistent, is highly available. But that's a single point on the network. What Big Memory, our product, does is brings those set of capabilities right into the application, so that this high availability, so that even though the data is kept in memory, there's a copy of it in memory in another machine. So if this machine is no longer available or goes down, the other memory in the other machine can take over. It's consistent, so if you have multiple servers, that the data the values are kept the same across multiple machines. It's persistent, so if you were to have a lights out failure in your data center, you could recover. But it's all in memory, so it's at a performance level that is orders of magnitude above the performance of reading and writing to disk, or reading and writing through a database layer to a disk, or reading and writing across a network through a database layer to a disk. So people who deploy Big Memory can get multiple orders of magnitude of performance improvement over the traditional methodology of using, disk-backed databases for their data.
Mm-hmm. Some of what you described, to me at least, seems a little counterintuitive to the idea of computing, processing, and storage being a centralized system. And it seems more decentralized in a way. So, how does what you're describing reconcile with the idea of cloud computing? How would you use Terracotta to enable cloud?
So, we've, from the get-go, at Terracotta, since we founded in 2003, have been about scale and performance. So being able to scale out, so elastically add more servers to do more computing, to manage more data, to do more. So using a software approach, saying, well, I can add servers easily, and in a cloud environment, adding a server is just like typing a command and a new server magically appears. So our software layer fits very well with that. So it is fundamentally decentralized. It's a scalable in-memory storage layer that will expand to meet the capacity requirements. So, you know, a cloud solution is this ephemeral environment where if you need to add more processing or storage capability, you can do so without, you know, physically having to order machines and rack them up and wire them up and so on. And so that this kind of software-driven approach to scale is absolutely essential within the cloud environment. And you know, customers can choose to use a completely off-site, you know, managed by someone else type cloud deployment, sort of public clouds even, you know, Amazon EC2 with our software, or they can use it within their own data centers, even so the software, you know, the data center may be centralized, but the deployment of applications is spread across the available resources. So it's a kind of an enabling technology which makes that jump between sort of the non-virtualized to the virtualized to the cloud, whether it's private or publicly managed, seamless.
Okay. Thank you. My last question is about the development community.
Yeah.
Yeah, so I understand this was an open source project originally, Terracotta. So you support a lot of developers, large community, that work with Java applications. What about some of the other development environments?
So we have primarily, we build an infrastructure technology which can be used from any development environment. So we have customers using our technology from within .NET environments or within JRuby environments or these kinds of other Python environments. We have focused on sort of the enterprise end of the market, which is I would say predominantly Java, where enterprises are building custom applications for transactional business logic that meets all the ITs. They go with Java, so we snap right into Java environments. And the open source angle is that those Java environments, those Java developers are already using cache, they're already using Quartz, they're already using the libraries that we build and make available to the open source community. Our commercial products just snap right in. So Big Memory has the same API as the open source cache, but goes to orders of magnitude more scale. We can deliver terabytes of in-memory scale through the same API that somebody might use just to manage a 1 gigabyte cache.
Hard to argue with that. Thank you so much, Mike. I really appreciate your insight today.
You're welcome. Thank you.
Thank you.